Okay. Okay. So I know last time we worked our way into the string trivia, but I'm going to kind of start it over again because I kind of blitzed it a little bit. So a couple things to note about strings. In Python, if you have a string, you can open it with and close it with double quotes or single quotes. I personally prefer double quotes, although it seems pretty standard for like everyone to like single quotes in Python. The reason I prefer double quotes is what's standard across, it's what's typical across most similar programming languages, where single quotes actually has different meaning. Like for example, next semester, all strings are like this in Java, but single quotes won't work, and single quotes are used to mean individual characters. So it actually has different meanings, so that's why I prefer it. And a couple of other reasons why I prefer it is if I go down here, here, I could use it here. If I do like A equals hello, print A, there. If I use double quotes, I can use single quotes inside of the double quotes and it'll work just fine. Where if I use single quotes, it's just going to get confused. Right? It's not going to know what's going on because you open, close, right? So you get a little bit like more flexibility there. Yeah, so in general, prefer double quotes. If you do single quotes, you're not wrong, but in general, prefer double quotes. You can concatenate strings. We've seen this for a while. If you use add, so the operator add is like, it's what we would say like is context sensitive. How and where you use it, it has different like functionality. If you add two numbers, it does addition. If you add two strings, it does concatenation.
You're not recording this lecture?
Yeah, yeah, I should be. Yeah, yeah, yeah. It's just my mic died, so it's plugged in here. If you're wondering what's going on, yeah. Yeah. We can repeat strings by multiplying them. Like here's a case. I multiplied it by 3. It just basically concatenates the string with itself that many times. You can convert ints to strings and strings to ints. Only if they're like admissible ones though. Like if I have like A equals 22 and B equals the int version of A, print A, oops, A type of A, and then print B type of B, whoops. Right? So A, well, it's a string, and then I converted it to an integer, and it's an integer, and then I can even do like C, which is the string version of B, right? Because B is the int version of A. We can turn it back to a string. Here. Oh my goodness. Nope. Right? So we went back. We can do that. However, this is only going to work if we have like strings that are actually numbers. Like if I do that, it's going to be like, well, I can't convert the string 2y2 to an integer. That doesn't make any sense. Okay? 2e2, I can't convert to an integer. It doesn't make a lot of sense. I think we can do this though. Or this won't work. Convert hello to an integer. That's not a thing. Yeah, okay, I guess that doesn't work either. Yeah, cool. Cool. So that'll only work if it will work. You can have a string that's an empty string. You open and close. There's nothing in there. It has length 0, but it's still a string. It exists, so it's not none. It exists. It's a string, but it's empty, which is an interesting peculiarity, but it's important. So here's what I'm showing here. A, it's this empty string. What's the length of A? It's 0. But what's the type of A? It's a string. And then we have some special characters. For example, like I was showing you last time. Like if I do this, print A, right? And you're like, well, how, like, what if I want world? What if I want hello and world to be on separate lines? How do I do that? Well, the only way I know how to add a new line is to hit enter on my keyboard, right? But that's not going to work for Python because Python's like, oh, it's a whole new line of code. But that's not quite right. That's going to be a problem. So how can I do that? I mean, one workaround is to just like, you could do something like this, I suppose. Right? Like, I guess that kind of works a little bit. But, you know, is there a way I can have, like, do it in one string? Yes. /n. The slash is like the escape character, which tells Python, okay, I don't want you to actually write slash, and I don't actually want you to write n. /n means new line. When I run this, we can see that it actually printed out that new line, which is pretty cool. We can do similar things with like /t. T means tab. So there you go too. There's several others, by the way. And then this begs the question, well, what if you want to like write slash though? If it's an escape character, it's not going to work. How do I, like, what's going on? You have to do //. Okay, well, actually that didn't work for a funny reason. /l. Here it's like confused. It's like invalid escape sequence /l. What is that? And you're like, well, I just want to print out a slash. Well, then you need to like use the escape character on the slash. You have to do like //, and then it'll be a single slash. So one little peculiarity there. Yeah.
So what if you wanted to print out a link, like with the HTTPS //
Then you would need //. You would need 4. You need to escape each one. Yeah. And then because strings are like delimited by like the quotes, what if you're like, well, I want to do like this, right? I want to print out hello world. How can I do that? Because Python's going to be mad at this. It's going to be like, this is nonsense. Well, you use the escape characters again. So if you really wanted quotes in your string, you need to like escape character with them, which is kind of neat. Any questions about that? There's a lot. I'm not going to exhaust the list of all different funny things like that you can do. I'm just showing you that like, oh, there's some options. So if and when the time comes, have a look at what you can do, and you'll find a giant list. Now, traditionally speaking, if we go back in time, like computers were small and they weren't very powerful, right? And they had it like, there's a long history of what this is. I'm not going to get into it. It's outside the scope of the course. It'll take too long to get into. But like, how many of you have heard of like bits, right? How about bytes? Yeah? Now a byte is 8 bits, okay? That means like 8 zeros and ones. That's a byte. And what's interesting about 8, right? So there's 8 zeros. That's 1 byte. Here's another one. There's another one, right? Here's another one. And so on and so on and so on. By the way, this is just counting in binary, which, by the way, have I showed you how counting in binary works yet? Yeah. I did. How it's the same as that we're used to. Cool. So this is just counting in binary. But with 8 bits, eventually I'm going to run out. That's okay, not that big of a deal. We have ways to kind of like address this. But there are 8. There is a finite number of different patterns I can have. Does anyone know how many unique patterns I can have with 8?
Whatever, 8 factorial.
Not 8 factorial. Not 8 prime. 256. How did you get that? 2 to the power of 8. And for those of you, how come? Look, you have 2 options. 8 times. Oh, look at that. Great. No, thank you. Why 2 to the 8? Well, you have 2 options, 8 times. Right? So it's 2 times 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 2. Right? Chances are, like, look, you'd have to go back a little ways, but I remember, like, learning that back in, like, remember, like, if you have 3 shirts and 2 pairs of pants, how many different combinations? You multiply them, right? It's the same thing. 2 options followed by 2 options followed by 2. It's just 2 to the power of 8. Anyways, that's 256. Now, traditionally speaking, within computers, it turns out that the bit pattern for, I don't know, like, okay, it's missing, okay. Let's just get rid of this real quick. Zero, 1, 1, 0, 0, 0, 0, 1. That is 97. If, traditionally, if you were to go to your computer and type into your computer something like this, A equals 97, this is not going to work like this in Python. Okay, it's not, but Python will like pretend it does because this is the way like it worked. Okay, if I were to do this and I say A is 97, that means the value 97 is saved somewhere. Okay, so I could go to my RAM and find one chunk of it, an 8-bit chunk, and I will find 011000001 to mean 97. It's in there somewhere. But it turns out 011000001, okay, that is an encoding, okay? I mean, 97 is kind of an encoding because we write the value 97. This is just how we write the number 97, but the number 97, like 97 exists if we don't write it down, right? You know what I mean, right? Like, how many apples do I have? 97. You're like, where's the 9 and where's the 7? Well, you don't need a 9 and a 7 to mean 97, right? So this is an encoding that means 97, okay? It turns out that this is an encoding that means A. It means the letter A. You're like, well, how can it mean 97 and also mean A? Because how we decode the encoding depends on the type. If I say, what is this value as an integer, I get back 97. If I ask, what is this value as a character, I get back A. So, as far as the computer's concerned, it's just zeros and ones. In order to decode those zeros and ones, we have to know the type. So types are an important thing, right? Now, this does lead to some interesting things, because you could be like A plus 7, right? And then like, but anyways. So what do I got here? So I can ask, and this, by the way, is like the ASCII table, right? It only goes up to 127, so only 7 bits would be here, but you could have another one. So the bit pattern associated with, let's see, the first ones are ones that you're not really going to see, but like exclamation point. That is the bit pattern that also corresponds to the number 33. The number 33 and the character exclamation point is the same zeros and ones. the number lowercase, or sorry, the letter lowercase a is 97, and yeah, it's 97 and lowercase a. They have the same bit pattern, which is kind of interesting. You can kind of convert between these in Python if you want. In other programming languages, this is even easier, but here's how you would do it. In Python, you could say, what is the ord? Python, I'm guessing ordinal. Ordinal, yeah. Ordinal means like an ordering. So if I say, well, what's the ord of A? It gives me 97. If I say, what is the character of 65? It'll give me A. Or not A, capital A, pardon me. Because capital A and lowercase a are different characters, right? So you got to be careful with that. But anyways, a neat little piece of trivia that you're probably not going to need to use at all. But it's really cool nonetheless. F strings. So any questions about any of that? This really gets into some of like the interesting weird history of like computers and how they work. And a lot of like how things are is just a consequence of it is what it is. It just kind of like evolved this way. There's reasoning where if we were to like start fresh and be like, okay, let's start over, we wouldn't do it the same way, but we're kind of stuck with it. Like, did I talk about the keyboards before? Yeah, like keyboards. Why are they laid out like that? Because the mechanical ones would jam all the time, right? Is that a problem today? No. Are we going to change the layout? No. People have tried. Is there any psycho in here that uses like Dvorak? No. There's usually one or two a year. You just don't want to admit to it. Yeah, you could change the layout, and there are better ones, but yeah, it's a nightmare. Anyways, F strings. So F strings are actually relatively new. They mean formatted strings. And they make like the following pretty easy. This is actually like, yeah, it's a relatively new feature added to the language. Like how long ago? When were F strings added to Python? 3.6. So yeah, kind of recently in the context of, what year was that? Year. 2016. Yeah. As far as I'm concerned, that's recent. They're a relatively new feature that everyone loves, that everyone wants other programming languages to steal this idea because it's a really nice, clean way. Because sometimes you have strings and you want to embed into the strings values, and so what do, right? Like if I were to say, like, A equals Bob, oh no. Well, 58, I don't know, right? And then print, my name is plus, no, A plus, and I am plus B old. No. And I forgot my plus, right? So here's what I'm trying to, by the way, this isn't going to work. Here's what I'm trying to do, right? I'm trying to like embed values from variables into my string, right? Not too bad, but I hit run and then it's like, oh, it's not going to work because I can't concatenate a string with an integer. B is an integer, right? Okay, but I can convert it to a string. There, okay. Oh, and then I forgot in the space. Cool. There, great, right? Not too bad, but definitely cumbersome. This is where F strings come in. And there are other ways of doing the same idea, but F strings is the recommended way to go about doing it, where you can inline, first you put a little F before your string, before you open your open quote. And then you can inline, if you use these braces, the squiggly brackets, it'll work just nicely. Way cleaner, way nicer. And what's nice about it too is it will automatically convert like integers to strings as well. You don't need to like explicitly convert it to a string. So the alternative here would be, come on, print f, my name is A and I am B years, no. Look, that's so much nicer, so much easier. I struggled far less. I didn't need to explicitly convert it to a string. It just kind of took care of it for me. It's a really nice feature of the language. Like the other things, I'm not going to be able to give you an exhaustive search of all the cool things you can do with f-strings, but they're pretty cool. For example, you can't see. I'll copy and paste it here. Come on. Cool. I zoomed out a little. Can you see that reasonably well at the back still? It's temporary zoom out. So I'm going to hit run. Okay, cool. So, how many of you have tried to print something out and you've got some funny issue where you've got a lot of decimals and you're like, do I really want all those decimals or something, right? Let's say you're calculating like a bill of something and it comes to like $1.4562222 some nonsense, right? You're like, well, that's meaningless. I only really want 2 decimal places, right? So what's kind of neat is you could add some like extra little like features here. You could say like the syntax for it is like colon and then .2 for 2 decimal places on the float, right? So there's a lot of these things. Don't ask me about them. You look them up and you'll find all the different options you have. I'll show you a few more. Right? Oh, here's one, right? Like imagine I'm trying to like format like a receipt, right? And you want everything to be lined up on that decimal, right? So if I do this, it's not lined up, right? Is it the end of the world? No, but wouldn't it be nice if they were all lined up? Well, you can pad. You can say, all right, I want this. I put in the literal here. This could have been a variable. It doesn't really matter, but I put in a literal. This means I want it to take up 8 spots in total with 2 decimal places, which is pretty cool. So whether the value needs all 8 doesn't really matter, but the point is it's going to take 8 and everything's going to be like lined up real nice, which is really nice. So there's a lot of cool features with f-strings. Yeah, this only scratches the surface. Don't worry though, you're not supposed to memorize all the things you can do. Just open up Google and like Python f-strings and it's like, oh, look at all these cool things you can do, right? Yeah. All right. Any questions? That was like the quick and dirty string trivia, right? There's a lot more I could have shown you. I'm not gonna right now. This is the type of stuff you just pick up as you go. All right, so I'm about to kind of jump like a month ahead, very briefly, to give you some ideas, and then I'm going to quickly jump back to today. All right? There is this concept of objects that we sometimes use when programming. Strings are an example of objects. What's neat about objects is, like an integer, what is an integer? It's the value that it's, like what's 5? It's the value 5, right? There's nothing really there to it. The string is a little different though, because the string, it's got its like value, but it has some like properties associated with it, right? Like it has a length, right? It might have like an encoding, like, oh, this is, ASCII or something, right? So there might be some extra properties like associated with that string. And there might be some extra like functionality associated with that string specifically. So there exist these things, objects, that are more than just like the basic types we've seen. They're still types, like a string has string type, but there's a little more to them. And like that warning, I'm going to keep this at a high level, and I'm going to make a lot of statements that are absolutely not accurate, especially in Python, but will give you like the general idea that I need you to understand, okay? The underlying ideas are going to be important, and the far more detail on objects will be introduced a little later in the course. So don't worry, don't freak out. So far we've seen some types. A lot of times we'll call these like primitive types. This is like a traditional name. This is like your integers, your floats, your booleans, okay? But we've seen strings, and we saw strings were a little different, right? You can index them. You can ask it its length, and so on. So strings are objects, and objects can work a little bit differently. We have seen built-in functions, okay? Like print. And we have written our own functions, like character is in, right? We wrote that one like last time. But there is this concept called, and of course we've seen variables. But like I just said, sometimes like the string, like that object, has a variable specifically assigned to itself. What I mean is the string hello has like a length, but the string goodbye also has a length, but their values are different. Everyone in here has a first name, right? But the values of your first name, so all of you are objects, and you have properties associated with you, like the instance of an object. Everyone in here has a first name. Everyone in here has a height. Everyone in here has like an eye color, right? So you all have the same values, like same like variables associated, but the values in those variables are different, right? Like, right? You see what I mean? My name is different than your name, right? We both have names. That's the idea. The same, there's also like, kind of like a similar-ish thing with functions. It turns out, like we have functions, but we actually can have functions that act on objects, which is a little different than what we've seen so far. It's not a crazy concept. It's something that you're going to get familiar with pretty quickly. But yeah, there's some functionality associated specifically with like instances of strings. So, do this activity really quick. Open up Colab, create a variable and assign some string to it and print it out. After running the code, type the name of the variable, press dot, and then wait. Sometimes you might need to press like space or tab or something. But do that real quick. Raise your hand when you're done. Okay, I'll give you like a few more seconds. It shouldn't take you too long. Okay, great. A dot. And you see a list pop up. All of these things with like little purple boxes are functions that will act on the string A. We call these functions that are associated with objects, we call them methods. It's just a function, but when we say method, we know, oh, it's a function that is like it's a part of like what a string is. The strings have this special functionality. They're called methods. if you're like raised, I know some people in here had experience with Java. Who here had experience with Java? So if you had experience with Java, there were no such thing as functions. You didn't have functions. The best you had were static methods. Everything you wrote was a method because everything in Java is an object. Yeah.
So I was under the assumption that methods and functions were the same thing until now.
Yeah, they're not. There is a nuanced difference. The functions are methods are functions that are associated with an object. Yeah. Yeah. So, if we look at these, there's a lot of things we can do, and I can scroll down. There's a lot. Like, what do you think will happen if I say capitalize? What do you think is going to happen? So notice, it's got open and close parentheses, right? And I hit run. Well, it didn't do anything. I guess maybe it returned. Sometimes it mutates, sometimes it, yeah, okay, cool. And you'll figure this out as you go, and that's a perfect example. I didn't memorize how this method worked. Let me explain. When I did this, I expected this to mutate. I guess it doesn't make sense because strings are immutable. But I expected it to modify the string, like to modify A, but this doesn't actually modify A. It returns a new string with the change that you wanted. So B equals that, print B. It's that string capitalized. Makes sense. It's a good method name. Dot.
Why didn't it do that?
It's, well, you did something wrong then. Dot. Let's see. Is decimal. This will tell you if the string is a decimal number. It's false. It's not. It's the string hello. Right? If I give you like 1, 2, 3, oh, it is. Right? And don't think decimal as like, oh, it's got like a dot. No, decimal as like base 10. Right? It's a regular old number. False. Is there like is? No. The point here is there's actually a bunch of functions that are associated with the string, with the string object. Okay? Yeah, okay, and then like I'll just do this one real quick. A dot upper. No, that's no good. It makes the whole string uppercase, right? There's some functions that are for strings are there. You may be wondering, well, actually, let's make sure, yes. So, you may be wondering, like, okay, so I'm saying a string dot upper. Okay, so presumably I have a string stored in the variable a string. And then I call upper, it's going to act on a string. Okay? Right now you might be like, okay, I guess that's how I do it. But you might be asking yourself, why is there just not a function called upper that I give the argument that I want to capitalize to? If you were wondering that, that is an entirely reasonable thing to ask. So why is it different? Honestly, it wouldn't have really mattered. Okay? Does it really matter? No. This was a design decision. The idea here is, well, this upper function is for strings. So let's kind of package them with strings. There, that makes sense because it'll act on a string. Effectively, too, by the way, when you have a method, you always have what we call the implicit argument. A string here is the implicit argument. It means that, like, well, this function is going to act on this, right? You could also have additional parameters, arguments, right? There's methods that might take additional arguments as well, by the way. Let's see if there are any that I can see. Count. I think count returns the count of like a specific thing. Yeah, 2, right? So here's an example of a method. It acted on the thing stored in A, and it counted the letters L. There's 2 L's in hello. Pretty cool. Again, if you're looking at this being like, how am I supposed to remember all of, like, I'm supposed to remember what's a method, what's a function, what methods are stored in the string class? No, you're not supposed to memorize that. That's, again, that's psychotic. This is something that the things you use frequently enough, you'll kind of just remember. And in all other cases, you just look it up. You go, how to make string uppercase in Python. And then you go, how do I do it? And oh, there's an upper method. Right, that's how I do it. That's how a programmer works, okay? They don't memorize this stuff. Eventually, you'll memorize it by virtue of using it, but that's how you do it, right? And in that example too, like, I didn't quite remember how that one method worked. Yeah, because I don't use it very often, so when I went to use it, it didn't do what I thought, so I used a little different. Oh, there we go. That's how it works, right? That's normal, that type of interaction, okay? Any questions about that? So in reality, there's nothing stopping us from writing a function upper, but with the string, the sequence of characters that make up the strings are stored in the object. The method is about the data within the object. The functionality that manages the data in that object will belong to that object. That's the idea. So how will I remember it? Don't. You're not going to. That would be weird. And again, yeah. Oh, look at that. Oh my gosh. I didn't do that on purpose. I have a link here that does the same. Make a string uppercase Python, and then it shows you. Cool. Any questions about strings and this quick little like, hey, objects are a thing, by the way. All right, cool. So objects are going to be coming up more and more as we go. Like lists are objects, but soon, soonish, we start covering objects explicitly on how we can define our own objects. So we can define our own variables, we can define our own functions. Well, now we can actually define our own objects, which is pretty cool. But that's for later. Okay, other questions? Anyone, thoughts, concerns, comments before we carry on? Everyone's happy? Awesome. All right, well, lists. You've all seen lists already. You've been using them whether you like it or not. There were lists in assignment 1. You used the for loop to iterate over it. You didn't really need to fully understand that to use it, but you know, they were there. We've been using lists if you've been doing caddis with that parsing, right? It's kind of ugly, but it is what it is. But lists, they're another collection of things. And it's almost like they're a generalization of strings. Where a string is a collection of characters, a list can be a collection of like anything. And you can even mix types. You can have a list with integers, strings, floats, and booleans in it. And you can have lists of lists of lists. It doesn't really matter. So lists are a collection of things. So I have an activity here. Run this code. Well, let's just do this together real quick. AV. I run this code. All right, cool. Sum list 5, 7, 9, 10. I print it out. Sum list. Print sum list at 0. We get 5. Why? Because it's at the 0th index. Because remember, indexes are offsets. Go to the beginning and take 0 steps. You're still at the beginning. Print 1 through 3. Who remembers what this was called? Slicing. Well done. That was you? Yeah, well done. Yeah. It's called slicing. It's a way to say, hey, give me like 1 through 3, right? And then what's the type? Well, it's of list, right? Its type is list. Cool. And there's a couple of things. Determine what types can be in a list. So if I've got integers, some other list equals Oh. True. 5. 7.123. Hello. And then a list with a false in it. But the string false, sure. Print some other list. There, right? So we can have a bunch of different types in there. We can mix and match types. It doesn't really matter. No. No. Who can tell me the length of this list? It's kind of a trick question. You can answer it, but it's kind of a trick question. Take a second. Lock in an answer. Don't say it. Think about it. Look at it. Count. You all can count. So I expect you to be able to look at this count and lock in an answer. Okay, raise your hand if you have an answer locked in. So for the rest of you, do you not know how to count? Like, what's going on here? Get an answer. I'm not going to ask you. You can be brave and raise your arm. Do you have an answer locked in? If you don't raise your hand, I'm going to ask you. Oh, hands went up. Perfect. Your hand's not up. No, it is. Is your hand up? It is. He's asleep. Are you awake? You are? So what's the answer? You don't know? 10? Close. No, it's not though. Same type though. Who wants to answer it for me? 4? 1, 2, 3, 4. Who thinks it's 4?
5.
5. Who thinks it's 5? Who thinks it's 6? It's 5. Why? Because how many unique, you were so close, right? You were off by double, yeah. You at least had it was an integer I was looking for at least, yeah. Why is it 5? How many things are in this list? 1, 2, 3, 4, 5. This list, although there's 2 things in it, it counts as one thing. There's one list there. So, len of some other list, it's 5. How can get the true out of this list? Who can tell me? This is definitely not a trick question. You should be able to answer this. No, just give me the thing at index 0, right? But 0, 1, 2, 3, 4. What is the list at index 4? It's that list, but it's that whole list, which is pretty neat. So, whoops. No. What will this give me? Let's get rid of this. What does this mean? It says go to some other list, go to index 4, 0, 1, 2, 3, 4, index 1. 1. It'll be the Boolean false. So you can actually index lists inside lists by just continuing to index. And you can do this for a long time. Can you access the last element in the list? Yeah. And the good news too is you can do that like syntactic sugar thing where you just do like a -1. Remember, it's not really indexing it with -1. This just goes in and says it's the length -1, right? Because that's the last element. There is no such thing as an index -1 for a list. Can we get the length? Yeah. Is it possible to have an empty list? Yeah. B equals this. Print B, type B. Right? In the same way that we can have an empty string, we can have an empty list. This is a list. There's nothing in it. It's a list, though. See? Cool. And, by the way, hold on. Let's do like A equals A, B, C. X. Okay, cool. Print X. Okay, does this shock anybody? Cool. Now, if I go here and I say x dot, we can see there's a bunch of methods. Pretty cool, right? One of the methods that we will be using is like append. What do you think append does? Here, and then let's do here, print x. Right, so what happened there? Okay, so it took the list, okay, ABC, printed it out, ABC. Now append to it D, ABC, D. Okay, seems reasonable, right? Nothing crazy? Yeah? Okay, let's get rid of that for a sec. Okay, yeah, okay, cool. What do you think's gonna happen? Everyone look, because I'm about to blow your minds. X dot append X. It didn't crash. Print X. Huh. What's going on there? What does it look like? What did I just do?
Print X because put X in the list, so then that would have, I don't know.
Kind of like
Yeah.
fold it into itself or something? Well, the good news is it didn't. There's a perfectly reasonable explanation for why we're seeing what we're doing, what we're seeing. I will get into that. But for the fun of it, okay, what's x at index 0? A. Okay, good. X at index, here, we can get rid of this. No. You can get rid of this one here. We don't need that. What's x at index 1? B. X at index 2? C. And then x at index, here, let's add the print x here. And then, okay, 0. Yeah, okay, so so far so good. 0, 1, 2, so 2 is C. 3, what is 3 going to be? A? This makes perfect sense. 3, it wouldn't be A, because 3 is this whole list, which is itself. Yeah?
X at 3 is X.
X at 3 is X. So what's X at 3 at 0? A. 2, C. X at 3 at 3? Is it self? I mean, I can just keep going. At 0. It's A. Cool. All right? Now you're going to be wondering, why would you do that? You wouldn't. Okay? But the sign of a good computer scientist is when you I'm showing you this because this is one of those situations where I tell you what the rules are. You can append things to this list. You can have different types in this list. What if you append itself to itself? Can we do that? Let's try. It didn't break any rules. What does that mean, right? It's that I know the rules. What can I do within this set of rules? That's where the fun can really happen, right? I will explain next time what this really means, but to give you a little hint, it was kind of like that idea that I showed you last time, where if I had a string A wasn't really the string A was a reference to it. So when I appended X to itself, I didn't actually append a list, I appended a reference to the same list. I'll explain it next time. Have a wonderful rest of your day.